Good morning, good afternoon, good evening, whenever it is you're joining us. Thank you for joining us. We are going to be covering section 10.4 conversions between moles and mass, and we're going to connect it to yesterday's lecture, which was about molar mass, okay? Because molar mass is the bridge between moles and mass, okay? How can we get more product? Okay, so let's say you are a chemist working at a manufacturing plant, right? You're one of those manufacturing plants for a big company, and you have a situation that we're going to read about. So, who's going to help me with the introduction?
Chemical manufacturing plants are always seeking to improve their processes. One of the ways these improvement comes about is through measuring the amount of material produced in the reaction by knowing how much is made. The scientists and engineers can try different ways of getting more product at least cost.
Perfect. Great reading skills, Miss Alexia. Thank you so much. So you're working at a factory. You're the chemist. They're telling you that you need to maximize your product. All right. Well, you want to always make as much product as possible to get into into the industry, and you want to do it at the least cost, right? Because the less it costs you, the more money the company makes, right? So, if you know how much is being produced in terms of moles or in terms of mass, or if you need either one, you're gonna use dimensional analysis. Okay, and dimensional analysis is one of those concepts that we talked about early in the semester. Okay, uh, but what dimensional analysis does is that it helps you convert from one unit to another. And the bridge, the conversion factor or unit that you're going to be using is what we learned yesterday, which was molar mass. So yesterday was very, very important. I told you it's going to be something that you're going to use probably for the next 6 weeks or longer. So don't worry. If you weren't here yesterday, we're going to review molar mass. So conversions between moles and mass. Anytime you're trying to, and remember, mass is always in terms of the gram, right? So you're changing grams to moles using that molar mass. And it says here, the molar mass of any substance is the mass in grams of 1 mole of representative particles of that substance. Don't get confused when they say representative particles, okay? Representative particles is just meaning it's just a word that can represent, and it even says it in the next sentence. The representative particles can be atoms, molecules, or formula units of ionic compounds. This relationship is frequently used in the laboratory. Suppose that for a certain experiment you need 3 moles of calcium chloride. Okay, so they're already doing a sample problem. They're telling you that molar mass changes grams to moles of whatever compound you're talking about. If you're talking about a molecule, if you're talking about atoms, if you're talking about formula units, it's just a type of compound. Don't get yourself confused with that, okay? Since calcium chloride is a solid, it would be more convenient to use a balance to measure the mass that is needed. The molar mass of calcium chloride is 110.98 grams per mole. We did that. That was a calculation for one of our questions yesterday. The conversion factor that can be used is then based on the equality that 1 mole is equal to 110.98 grams of calcium chloride. So dimensional analysis is going to come in. Dimensional analysis will allow you to calculate the mass of calcium chloride that you need to measure. Okay, and this is the way they set it up. And it looks really, really confusing. I know. Every time we do this concept, my students start to freak out. Don't freak out just yet. Miss Hernandez over here has a strategy that's going to make things so much easier. All right. But let's discuss what we see in front of us. We know that we have 3 moles. We know the molar mass of this compound, calcium chloride, is equal to 1 mole. we can use this conversion to cancel out moles and change our unit to grams. That's all we're doing here. Moles cancels with moles, and you're left in grams of calcium chloride. Now, the only thing that's left to do is to run the math. And you always have to think, this guy has an imaginary line, just like you see here. It's a fraction also, right? It's over 1. So that means this number's on top, this number's on top, and when you have two numbers on top, you multiply. And that's where they're getting this 333 grams of calcium chloride. And you can get a calculator and you can do it on your phone or whatever calculator you have, and you can prove that this is correct by just multiplying 3 times 110.98. And then it says here, when you measure the mass of 333 grams of calcium chloride, you are actually measuring 3 moles of calcium chloride. Just makes things simpler. Don't worry if this looks confusing. Don't worry. I got something up my sleeve that's going to help you. But first, before we get into any of the math stuff, what is the concept? What is the conversion factor that is needed? And you don't even have to think of the numbers. Don't think of the numbers. What is needed to change grams of sodium chloride to moles of sodium chloride? What did we say they used in the example in the last slide? How do I change grams to moles? What is the connection between there? What am I going to use that we learned yesterday? Big hint. That's going to help me do this. And I got one response. Somebody's typing. I don't want to show their answer just yet. I just want to let you think about. The rest of you, I want you to just think about, what did we talk about yesterday that we need for today? Okay, you're already setting it up. You don't have to do that just yet. What do I need from sodium chloride to change grams to moles? What was the topic from yesterday? What is it called? What was the topic? What did I say that we discussed yesterday? What was the name of the topic? Anybody remember? Anybody? It's got the initials MM, M, and M. What is it? Initial M, M. What do you think I'm talking about? You need to go back? What do we need to go back? Let's go back. It says here. It says here at the beginning. What does it say in the beginning? What did we say this 110 equals? Where did I get this 110.98? What's it called? Anybody? Can you post it in the chat on Google Meet? Somebody? What was the topic from yesterday that's here highlighted in green? Molar mass. Yesterday's topic was all about molar mass. So what do I need in order to complete this question? I'm going to need the conversion factor that is known as molar mass. All right? Molar mass. Got it? Hello? Do you hear me? I don't hear any response. I don't see anything in the chat. How do I know that you're listening? What was the conversion factor that we need to change grams of sodium chloride to moles? Hello? Anybody listening? I don't see anybody answering. So I'm going to stop until somebody responds to me. So yes, it's all about the molar mass. So here we have, anytime you're learning this concept, it's all about practice. So they're going to throw at you sample problems. And don't worry, like I said, there's going to be a strategy that's going to help you understand what to do. And here you have a picture of what calcium chloride actually looks like. America, nice to see you, Miss America. Where have you been? So America and Irvin just snuck in. All right. So it says here, chromium metal is used for decorative electroplating of car bumpers and other surfaces. Find the mass of 0.560 moles of chromium. And step 1, always list what you know and what you don't know. Okay? And think about what you have to do. So what do we know? Well, we know the information that they gave us. They're giving us 0.560 moles of not a compound, of an element, chromium. So we have our given info, 0.56, and we know the molar mass of chromium, right? If we go to our periodic table and we look for chromium, element 24, we know that the mass of this compound is 51.996, which rounds to 52 grams per mole. We're going to use that information to solve and change moles of chromium to grams of chromium. All right, so we're going to have to do a conversion factor to do this. And I'm going to go into Jamboard so that I can show you what to do. All right, but first, let me talk about this strategy that I'm going to tell you about. All right, everybody write this down because you're going to need it. Okay, please write this down. Anytime you have grams and you want to change it to moles, did that a little too big. There. So let me draw an arrow. See this arrow? And another arrow. All right, so let me show you the cheat sheet version of this. Okay, so anytime you are given grams, so I'm going to put up here given, and this means you're given in the problem. If you're given grams, you will divide your given grams with your, what does MM stand for again? Jeremiah, you said it earlier?
Molar mass.
Did you hear what he said? Molar mass. MM means molar mass. That's an ugly M there. Now, if you're given moles and they're asking you for grams, you're going to use that bottom curve. And you're going to take your given moles and you're going to multiply now by MN. Jeremiah, what is MN again? Wait for it.
Molar mass.
There it is. Molar mass. Molar mass is the key that you need in order to change grams to moles or moles to grams. Okay? So keep that in mind when we're working on the question right now. All right. So now we have this much moles, right? So my given, that's my given right there. Whatever's in the problem, that's your given. So I have moles. They're asking me to find the mass. Mass is grams. What does the strategy tell you to do when you have moles and you're going to grams? Top or bottom strategy? Top or bottom curve, whatever you want to call it. You're starting with moles, going to grams. Which curve is going to take you that way? Is it the top curve or the bottom curve?
Multiply.
Yeah, it's the bottom curve. It says here, if you're starting in moles and you need to go to grams, you're going to follow the bottom curve. And the bottom curve says you need to multiply. All right, everybody got that? Okay, so let's go back. So I'm going to take my 0.56 moles and I'm going to multiply, right? Because that's my given. I'm going to multiply by the molar mass. They told me that the molar mass of chromium, which we found on the periodic table, is 52 grams. Oops, I forgot to put per mole. So everybody get a calculator, which means I'm talking about your phone, just like I am. 0.56 times 52. What'd you get? Did anybody try it?
29.12.
Very good. 2912. Look at that. Great. Perfect. So then look at what you have. You have moles. So moles cancels and you're left with 29.12 grams. What do you think? Yes, no, maybe so. Kind of get it? Yes, no, maybe so. Kind of. Let's do another one. Oh, and let's go to the next page so we can see the answer. Let's see it. Let's see. Look, they got the same thing that we did. 29.1 grams of chromium. Great. Look at the way they set it up. Isn't that so confusing? It's the same thing we did, except our setup is just a little easier to understand for you guys. Okay? I understand what they're doing. So, and you can see here that the moles cancel with the moles, and you're left with grams. Okay? All right. So, it says here, since the desired, so it says to think, since the desired amount was slightly more than 1/2 of the mole, the mass should be slightly more than 1/2 of the molar mass. So now they're talking in terms, okay, if I have 1 mole and this is talking about 0.56, it's a little bit more than half of a mole. So if I have 52 grams of my molar mass, it should be a little bit more than half, which it is. If you look at the answer, 29.1. The answer has 3 significant figures because of the 0.560 moles. Don't worry about significant figures. That's more for like pre-AP and AP. We don't really, we talk about them. I don't think we talk about them too much. Okay, but if you need me to teach you significant figures, I can teach you significant figures after school. A similar conversion factor utilizing molar mass can be used to convert from the mass of a substance to moles. So right now it was all about moles to mass. Next, they're telling you in a laboratory situation, you may perform a reaction and produce a certain amount of product, which can be mass. So now they're talking in terms, well, what if your answer is in mass, in grams? It will often then be necessary to determine the number of moles of the product that was formed. The next problem illustrates the situation. So, anytime you're in the lab, you're going to be weighing your product, and it's always going to be in terms of mass. So what are you going to do? Well, you're going to do the opposite, right? We multiply to go from moles to mass, to moles to grams, right? Well, if we go backwards, we're going to divide, right? Here's problem number 2, sample problem 2. A certain reaction produces 2.81 grams of copper 2 hydroxide, CuOH2. Determine the number of moles produced in the reaction. And remember, always list what you know, what you don't know, and think about what you have to do. So what do we know? We know the mass is 2.81 grams. We know that they're asking for moles of this compound, which is copper hydroxide. So we need to think, okay, I'm given mass. I need to go to moles. What do I need to do? So let me go to Jamboard. I'm in mass, right? Grams. I need to change it to moles. Top or bottom curve, real quick. Which one is going to take me? The top curve or the bottom curve? What do you think? I'm in grams. Do I take top or bottom? Very good, Miss Diamante. So what does this mean if you are seeing this? What does this guy mean right here? What does this line mean mathematically? What am I going to do? Over here, I multiplied. Oh, what do you think this guy is going to do? And MN mm is molar mass. So do I have the molar mass? No, they don't give it to me. So what do we have to do? We got to go get it. We got to do it. We got to calculate it. So look at this. I already have everything ready here. I have a blank page so that we can do molar mass. So my compound is copper 2 hydroxide, right? So I got CuOH2. So let's review molar mass for those of you who weren't here yesterday. You always make a list of your elements, right? Cu, O, and H. Now you need to list how many you have, right? What number is here that you don't see? A 1. Okay, so for copper, it's a 1. For oxygen, it's a 1, but it's in parentheses and a 2. What did we say we do when we have a number outside the parentheses and a number here? What am I going to do here with this guy? What does this little x mean in math?
Multiply.
Yes. So 1 times 2, Jeremiah? 2. Again, same thing. I got a 2 on the outside, so what do I have to do here? Multiply. 1 times 2? 2. Now I'm going to multiply by the mass of each element. So I'm going to go to the periodic table. Remember, I told you, keep a periodic table handy. Copper. Everybody see it right here? Hold on, let me highlight it. 63.55. 63.55. Oxygen. Do you guys remember it from yesterday? 15.999, which rounds to 16. And last but not least is hydrogen. 1.007. It's going to round, right? Everything always rounds. 1.01. All right, we got some easy math, right? Multiply, and after you multiply and get all the answers, add them up. The first one, 1 times 63, that's easy. 63.55. 2 times 16, another easy calculation. Well, at least I always know this one. 32. And you can prove it with a calculator. 2 times 101, that's easy math. 2.02. Add them up. Add them up and tell me what you get. What'd you get? I have it, but what do you have? You guys should be trying it out.
Lo hacemos a todos juntos.
Very good. That's what I got, girl. Excellent. 97.57. Okay. So now that I have 97.57 grams per mole, right? That's molar mass. This is molar mass of our compound. Very good, Alexia. So I'm going to take this information and I'm going to use it over here. Now I know the molar mass of copper, 97.57 grams per mole. Okay? So let's go to the strategies. We already said we're going to multiply, right? Diamante said we multiply grams and molar mass in order to change. Oh, I'm sorry. Did you say multiply or divide? I don't know. Let me see. We're going here. We're starting in grams, going to moles. Let's double check our strategy. We're in grams. Going to moles, we said we're going to divide. Okay? We're going to divide, right? This guy means divide. All right. I just wanted to double check and make sure we're doing it right. Okay. So remember, it says here, and don't forget, oops. It says here what goes on top, what goes first. You're given. Meaning, what did they give you in the problem? This is what they give me. This is what goes first. Okay, so 2.81 grams divided by your molar mass. It's going to be a very small number, 0.0 something. 0.0 something, guys. What did you get? And I'm not making a phone call. I'm just waiting. Very good, Miss Alexia. 0.028. If you round it, it's going to be 0.0288. And my unit, my grams, cancel my grams. So my unit is the mole. And it already tells you right here. What do you think, guys? Is it getting a little easier? On a scale from 1 to 10, what would you say? 10 being, I understand it, miss. And 1 is like, I'm still lost. Where would you be from 1 to 10? 10. Great. The strategy really helps, right? The strategy really, really helps. If you know what to do with this guy, no problemo. Okay, and I got some really, really sharp kids in here. Okay. All right. And it says, look at that. Boom. Exactly what we got. Exactly what we got. I've been getting a lot of spam calls. I hate it. Okay, let's see. What's next? Uh-oh, now it's your turn to practice. Okay, but before we practice, do you think we're going to need the molar mass? Even if, before we look, it says here, a synthesis reaction yields 90 grams of sodium chloride, NaCl. Calculate the number of moles. That's number 1. Number 2, how many grams are present in 1.75 moles of sodium chloride? Okay, so we're talking about the same compound. It doesn't matter which one I'm going to tackle first. What do both of them need? Both of them are going to need molar mass. So that's where we're going to start. We're going to start by calculating the molar mass of NaCl. All right? Let me clear this one. It's real easy, right? Because it's only Na, sodium, and Cl, chlorine. And there's only one of them, right? Everybody agree that there's only one of each? We agree, right? One. We agree. We definitely agree, Irvin. So, what about sodium over here? How much does it weigh? 22.99. Everybody see that? How much does chlorine weigh? 35.45. So 22.99, 35.45. You got it? 22.99, 35.45. Well, any number times 1 is the same number, isn't it? Yeah. So add them up, because that's the last part of molar mass, Irvin. And give me what you get if you add them. I always do that. It's 50 something, I believe.
58.44.
Boom! Go, girl. You go, girl. Everybody got that? 58.44?
I already had it in my mind.
You better. Pero no lo dijo, ¿verdad? No cuenta si no lo dijo. If you don't say it, it doesn't count. So now we have we have molar mass, right? Okay, we got the key. Let's unlock the question. All right, so it says here, synthesize. It says we're given. What's our given? What's our given, guys? I don't hear anything. What's my given? What unit are they giving us? What number are they giving us? What do you see here that they're giving us? 90 grams, exactly. It's all about these 90 grams. And they're trying to change these 90 grams to moles. You see that? So we're starting in grams, going to moles. That's what we got to do. What is the strategy? I can't say it. The strategy. What does it say to do if you're given grams and you're going to moles? Divide, multiply. Those are your options. What are you going to do? You're given grams. Dice Diamante que, that you have 90 grams. Tienes que cambiarlos. You need to change them to moles. What you going to do? Top or bottom? You have grams. Divide. Yes, ma'am. And always put your given first. Your given always goes first. So what's our given? 90 grams, right? We got it in the chat. So for number one, we're going to take our given 90 grams and we're going to divide by our molar mass. Okay, that's number one. Number two, you know what? Let me do it a little further this way. Number two says, well, what's the answer for the first one first? What do you get? Let me move that from there in case you get confused. Come on, Irvin. What's the answer?
3.16.
Whoa, whoa. We're 3.16. Let me see. Let me double check, y'all. 90 divided by 58.44. I got something different. Did anybody else get something different? Did you guys divide? Double check your work. Did you divide? Somebody double check their work. I got something different. Try it again, guys. 90 divided. Huh? Yes. I ended up with not 1.55. I ended up with 1.54. Okay. Did anybody else get that answer? I got 1.54 moles. And it makes sense because I got 90 as my mass and I got like half of my molar mass, right? So it would be 1 point something. Okay, so 1.54 is correct. Is that what you got, Diamante or Caitlin? You're still getting 155? No, it's 1.54. Okay, yeah, okay, 154. You see, Alexia got the same thing. All right, next. Now, in this question, you're given moles. You're given moles and they're asking for you to change it to grams. What's going to happen? What's my strategy? I'm over here. I need to go and I need to change it to this guy. What needs to happen? Thank you. We need to multiply, right? We're going to take the bottom curve, and the bottom curve says you're given moles and you're going to multiply. So you're going to take, oops, I don't write on here. You're going to take 1.75 moles times our molar mass, 58.44 grams per mole. What 2.27? Let's verify. Who else got a number? This is what I got.
Let's go.
102. Hold on, guys, just a second. Hey, what's up? Yeah, I'm back. I've been here since the beginning of. I got here just in time for 5th period. There was a lot of people. Thank you, Coach. Bye. Okay, let's finish up. All right, we don't have time to do the video. Don't worry, I explain it better. Calculations involving conversions between moles of a material and mass of that material are described. Your review questions. Oh, this one you can do and think about. You have 19.7 grams of a material and wonder how many moles were formed. Your friend tells you to multiply the mass by grams per mole. Is your friend correct? And then it says, number 2, how many moles of magnesium oxide are in 3.5 moles? Number 3, how many moles of water are in 15.2 grams of pure ice? All right, that's what we're going to tackle next. But let me stop recording first.